What is going on, guys? Welcome back. In this video today, we're going to learn how to easily build machine learning applications using Streamlit, meaning no HTML, no CSS, no JavaScript, but a nice front end for your machine learning application. So let us get right into it. Alright, so we're going to learn how to easily build a machine learning application in Python today, how to build a frontend for a machine learning application in Python, and we can do all of this without having to write any HTML, CSS, or JavaScript code by using a package called Streamlit. Streamlit essentially allows us to define the user interface, the web UI, using only Python code in a very simple way, and we can still end up with a good-looking and professional interactive web application that uses our machine learning model in the background. Because if you're anything like me, you really enjoy doing all the machine learning work like building the model, training the model, evaluating the model, doing the hyperparameter tuning, pre-processing the data, and so on. But you're not very interested in building a user interface around it, especially not a web user interface with HTML, CSS, and JavaScript around it once you have everything done and ready to use. So this is something that you can do easily with Streamlit and professionally with Streamlit with less effort. So we're going to start here by installing a couple of packages. The goal for this video today is to train a very simple image recognition model on the Cypher10 dataset and to then use this model in a web application. So to build a web application around this model so that we can upload images and classify them in the web browser without having to write, again, any HTML, CSS, or JavaScript code. So we're going to start with the installations, pip or pip3 install numpy, matplotlib, then pill, or actually pillow, sorry, pill is the name that we use for the import, then also TensorFlow for the actual model, and of course Streamlit, the package that we use for the UI. Once you have all of this installed, we have to import a couple of things. So we're going to start by importing numpy snp. We're going to import matplotlib.pyplot as plt. We're going to import Streamlit sst. From pillow, we're going to import, now I wrote pil in the command line and pillow here. It's the other way around. So you install pillow, you import from pil, capital PIL. We import the image class, and then we also have to import a couple of things from TensorFlow. So from TensorFlow keras.datasets, we're going to import the Cypher10 dataset, so Cypher10 like this. For some reason, my PyCharm doesn't recognize that I have keras inside of TensorFlow. I don't know exactly why that is, but it still works when I run the code. So from TensorFlow keras datasets import Cypher10. From TensorFlow keras.models import sequential. From TensorFlow keras.layers, we're going to build a very simple model, a simple multi-layer perceptron with a flatten and some dense layers. And then from TensorFlow keras.utils, we want to import a to_categorical function. And I think that's it for the imports. So those are the imports. Again, NumPy to work with arrays, Matplotlib to display plots, then Streamlit to build the user interface, image to work with the images for the classification, and then all this stuff here for the TensorFlow model that we're going to build. And we're going to have two parts here. First of all, I'm going to write a script that trains a model, the Cypher10 image recognition model, and then I'm going to use Streamlit to actually use that model. And actually, I think we also need to, I'm going to just import here at the top, import TensorFlow STF, because later on, we're also going to load models that we stored. So we're going to use TF, and then we're going to load the model from there. So we're going to just, first of all, load the data, then we're going to pre-process it, and then we're going to train a model on it. This model will then be exported, and then we're going to import it for the actual Streamlit application. So we're going to say here, x_train, y_train, and then also x_test, y_test are going to be equal to Cypher10.load_data. So Cypher10 is just a data set with 10 different categories. We have images of planes, ships, trucks, cars, and different animals. I think we have horses, deers. I'm not sure what exactly all the classes are, but we have 10 different classes that we have to classify. And this is now the training data and the test data. They're split up in these two tuples. And what we're going to do now is we're going to say x underscore train is equal to x underscore train divided by 255. And the same thing for the test data. Why do we do that? Because the values that we have here are pixel values, RGB pixel values between 0 and 255. So when we divide all of them by 255, we get values from 0 to 1, which are better for the neural network to work with. So this is going to increase our performance. This is now pre-processing. For the Y-train data, we're going to use the toCategorical function. So to underscore categorical Y-train, and we need 10 categories here. Same thing for the test data. And that is basically the pre-processing. We don't need to do any fancy stuff here. And now we're going to just say that the model is, and it's going to be a sequential model with the following layers. We're going to pass a list here, and we're going to pass some layers. A simple flatten layer with the input shape, input underscore shape, is going to be equal to 32 pixels times 32 pixels with 3 color channels RGB. This is going to be flattened into a 32 times 32. What is that? I don't know. Let's see. Calculator. 32 times, where is it? 32. 1024. So this is going to be flattened to an input layer like this. Then we're going to have a dense layer, which is just going to have 1,000 neurons. And it's going to have a simple ReLU function. So activation equals ReLU, rectified linear unit. And then we want to have a dense layer with 10 neurons for the output for the actual classification. And this is going to have activation is going to be equal to softmax. So softmax basically a function that gives us the probability for every possible category, and all the probabilities sum up to 1. So we have 100%. Yeah, this is a very simple model. The goal is not to build the best possible model here. I want to show you how to take that model and put it into a Streamlit application. But this is the model. We want to compile it, model compile, with a loss function of categorical, or actually sparse categorical cross entropy. And then we want to use an optimizer atom. Now, am I blocking this with my camera? Not yet. And then we also want to have the metrics. The metrics are going to be just accuracy, like this. So this is the compilation. Now we can fit the model on the X train, Y train data. Batch underscore size is going to be 64 epochs. We're going to train this for 10 epochs. And we're going to use the data as validation data. Why not? Because we don't necessarily need to have testing data. We're not going to evaluate the model. We're just going to pass here X test and Y test. And I had this in a previous video that I made recently, that I used the test data as the validation data. So to keep this clean, let's just call it X underscore val and Y underscore val, because if you're using it as validation data, it's not test data. So that is that. And the final thing is we want to save the model. So model save, and then we want to save this in a file. Let's say cipher 10 model.h5. So when I run this now, this should train the model. I'm not sure how accurate it's going to be with just one dense layer. What's the problem here? Is this because I'm using sparse? Should I actually use just categorical cross entropy? Maybe. Yeah, seems to be the issue. So this is going to train out 10 epochs. We're going to skip that. I'm not going to let you watch that. It's going to take some time. And then we're going to take the model and build an application around it. All right, so the model is now trained. You can see the accuracy is not very high, but it doesn't really matter because, as I said, I didn't want to train now a professional convolutional neural network. This is just some model that we can use. And now we can get rid of all this. We have the file with the model. We can also get rid of these imports. We're going to keep this one because we need to load the model. And we're going to keep all of the rest here. So maybe we can reorder this a little bit like that. And what we're going to do now is we're going to build the Streamlit application around the model. So we're going to take the model and it's going to perform functionalities, or it's going to perform the predictions, and we're going to build a user interface around it with just Python in a very simple way. So we're going to define a main function here, and in this main function, we're going to start by saying st.title is the title of our application. For example, Cypher 10 web classifier or something like this. Then we're going to say st_write, and we're going to have just some basic text like upload any image that you think fits into one of the classes and see if the prediction is correct, something like this. And then what we want to have is we want to have an upload for an image. We want to have a possibility to upload an image to the web application. And we can do that by saying st.fileUploader. And in here, we want to say, please upload an image. And the types that we accept are going to be JPEG and PNG. And we want to have this in an object. So file is going to be st_fileUploader. And then we want to say if we have a file, then we want to do something. Otherwise, we want to have a text. So text is going to be you have not uploaded an image yet, something like this. So that is if we didn't upload an image yet. And otherwise, we're going to process the image, we're going to feed it into the model, and we're going to see what the model says about this image, so what it predicts this image to be. And we're going to do that by saying image equals image from pillow now, image open. We're going to open the file. This is going to be a path to a file. If there is no file, so if we didn't select a file, it's going to be none. Otherwise, it's going to be the path to that file. And we're going to say now st_image. We're going to have the image itself from pillow. And we're going to say use column width equals true. And now we want to actually pre-process the image for the model. We want to load the model. We want to make a prediction. And then we want to show that prediction. So first of all, we're going to say resized_image. Because remember, our model is trained on 32 by 32 pixel images. So if we have something that's not this size, we have to turn it into that size because our architecture has an input shape of 32 times 32 times 3. So 32 pixels times 32 pixels, 3 color channels. So the resized image is going to be image.resize. And we're going to pass here 32, 32. And then the image array is going to be equal to np array, and it's going to be the resized image divided by 255. Because remember again, we had values between 0 and 1 when we trained the model because we did the same pre-processing. Now we have to divide by 255 as well. So what's the problem here? I think we can ignore this. So we have this image array now, and we can say also again image array equals image array dot reshape, and we can reshape it into the following shape 1, 32, 32, 3. So we have one image of size 32 times 32 with 3 color channels. That's hard to pronounce. So we're going to say now model equals, and then we're going to say tf keras models load underscore model, and we're going to load our Cypher 10 model. So Cypher 10 model H5. And this model is now going to make a prediction on this pre-processed image here. And we're going to say predictions equals, actually no list model dot predict the image array. And then what we want to have is a list with the classes. So Cypher 10 classes are going to be, and those are going to just be now the names of the classes. I got them from the documentation. The first one is airplane. The second one is automobile, like this. Then we have a bird. Then we have a cat. Then we have a deer. Then we have a frog. Then we have a horse. Then we have a ship, and finally we have a truck. Those are the 10 objects that we can recognize, and we want to know now which one is it, and we can find that by just getting it from the classes list and using the argmax of the predictions. For this, we're going to now say figure axis is going to be equal to, or actually figure axis like this, is going to be equal to PLT subplots. And we're going to say y underscore position is going to be equal to NPA range, length of the Cypher 10 classes. Because what we want to display here is we want to display not just the highest value. So we could go ahead now and take these predictions and get the argmax and then get this index and just display the word. But what we want to show is we want to show a bar plot showing the confidence in each of the classes. So it would say this image is 0% airplane, 2% automobile, 3% bird, 85% cat, and stuff like that. So we want to have the individual values, confidences, or probabilities of the softmax function. So we're going to have the positions for the individual classes like this. So like this. Then we're going to say axis bar h, and we're going to say here y positions. Then we're going to have predictions 0. Align is going to be equal to center. And then we just need some basic styling. So set underscore y ticks are going to be the y positions. Axis set underscore y tick labels are going to be the classes. So the Cypher 10 classes. And by the way, all of this is now just matplotlib stuff, right? So this is not Streamlit stuff. So everything that we do here is just the design of the plot. If you just want to print a text, you can also just have an st text showing you the class. This is also possible, but I think this is more impressive here for the visual results. So we're going to have the y-tick labels. We're going to invert the y-axis. And we're going to then also say set underscore x label. And the x label is going to be the probability for this particular class. And finally, we want to have a title. So axis set underscore title is going to say Cypher 10 predictions or something like that. And finally, we want to say st, so Streamlit dot pyplot. And then we can just pass the figure, the matplotlib figure, to plot it inside of our Streamlit application. So to go through this again, we trained a model, then we create now a Streamlit application. We have a title, we write some text there, we give the user the possibility to upload a file. If this file was uploaded, we do something. Otherwise, we just say you have not uploaded an image yet. If an image is uploaded, we take it, we load it, we resize it, we turn it into a NumPy array divided by 255 to get values from 0 to 1. We reshape it into 32 pixels, 3 channels, and 1 instance. We load the model that we trained. We predict, we make a prediction. We get the classes list. We get the individual probabilities. And then we design a simple plot, a bar plot that shows us for each class how confident it is that this is the correct answer. So this is what we need. We're going to launch this now from a terminal. So we're going to navigate to docs, to programming, to neural 9, to Python, to current. This is my directory that I'm working in. And here we're going to now say Streamlit run main py. Streamlit run main py. This is going to open up the web browser. And then once this is done, nothing happens because I didn't call the main function. So we need to say also if underscore underscore name underscore underscore equals, and then the string underscore underscore main underscore underscore, then call the main function, because otherwise we're not going to get anything here. So again, command line, rerun the command. And now we should have a user interface, hopefully. There you go. Cypher10 web classifier, upload any image that you think fits into one of the classes. Please upload an image. You have not uploaded an image yet. Browse files, and I can go now to documents, to programming, neural 9, Python, current, and I have here a couple of images. I have a horse, I have a bird, and I have a car. So I can upload the horse here, and we have a problem. Why is that? Mismatch is between arc2 with shape 10. Let me see what the problem is here. Which line are we talking about? Probably something in the plotting, right? Let's see, we have the Y positions. We have the Cypher10 classes. Did I skip a class or something? I skipped a class. Yeah. After deer, we have dog. I skipped the most important animal, dog. Okay, so we have these 10 classes here. So let's rerun this again. Let's upload the horse again. And as a result, you can see we have here the probabilities. This is most likely a horse. It could be an airplane for some reason, a bird, a truck. So yeah, horse is fine. Let's see if it also recognizes the others. So we have a car here. Okay, it's definitely a car, as you can see. Maybe a truck. This is reasonable. And then we have the bird. The bird is, it's not very confident. It would say it's a bird. That's fine. But it could also be a deer or a frog. So yeah, probably if we have a convolutional neural network, it would recognize this clearly as a bird. But yeah, you can see it got all of the three right. This one was not clear to it, but you can see this user interface here is very professional, very good looking. And we have a file upload. We have the possibility to display images, to display plots. And yeah, this is just a professional web application, a professional machine learning application, and we didn't use any HTML, CSS, or JavaScript. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.